So the first, it asks to find the parent function, the domain, range, equation of the asymptote, end behavior, and transformations.
Okay.
And the equation is y equals 1/2 parentheses 4 parentheses to the x.
What's the parent equation?
Y equals 4?
To the x.
Okay.
In other words, what distinguishes this function from most functions is it's not an algebraic function. It's an exponential function.
Mm-hmm.
And what makes it exponential is the fact that the variable is in the exponent.
Right.
Okay? These all look just like that. And when I say all, I mean whether it's 4 to the x or e to the x or 14 to the x. They're all going to go through that point, which is 0, 1. And
Okay.
they're all going to have this shape. Okay? So what is the one transformation that's happening to the black curve by our function?
The transformation?
Yeah, what's the consequence of that 1/2? That's the only difference between what we have and the parent function.
A vertical shrink.
Correct. So let's start with this point. Where does this point go to?
Well, it's applied to the x value.
Actually, it's applied to the y value.
Oh, okay.
Remember that vertical transformations all apply to the y value. Horizontal transformations always apply to the x value.
Okay.
So this point, the only point that I really know for sure on that curve, gets cut in half, becomes 0, 1/2, and the curve is going to look not that much different. I don't know whether it actually crosses the black line or not, but it's a shrink and not a stretch.
Okay.
So, yeah, in fact, I do know when it crosses the black line. It doesn't. In other words, everywhere the red curve has to be half the distance of the black curve because it's being shrunk. So the red curve is going to look like that. Okay, what else do you got? Got another one?
Oh, for that.
Oh, that's right. There were more stuff involved there.
Yeah.
You needed asymptotes and all kinds of stuff.
Yep.
Let's see. What kind of asymptotes do we have?
Well, that
Line or the black line, they both have the same asymptote. What is it?
is it just? It's an x equals equation, right?
It's a y equals. It's a horizontal line. All horizontal lines are y equals some number.
Okay, so I think it's y equals 0.
Correct. That's the horizontal asymptote for both. Y equals 0, which is the x-axis. That's why people get confused, because it's the x-axis, but the x-axis is y equals 0.
Okay.
Okay, is there a vertical asymptote?
It doesn't ask for that, but...
Well, there isn't one anyway. In other words, there's no vertical line here that this thing gets asymptotic with. In other words, I can go as far as I want to the right on the horizontal axis. It just keeps going up on the y-axis. Okay, so the end behavior is infinity as x goes to infinity. Want a domain and range?
Yep, so I think domain is always negative infinity to infinity.
Mostly with exponential functions it is. In fact, it might be always, unless you get a more complicated one. What's the range?
Um, is it 1/2 to infinity?
No. How low does the red line go?
Oh, to like,
Almost. If you go far enough to the left on the x-axis, that red line gets closer and closer to 0.
oh, okay.
So it goes 0 to infinity with a parenthesis around the 0 because it never hits 0. That's why y equals 0 is a horizontal asymptote, is because the curve will never hit it. It'll just keep
Okay.
closer and closer to it. So it's 0, in other words, are you giving these answers in interval notation?
No.
All right, well, that would be interval notation. 0 to,
Oh, what you just wrote?
yeah,
Oh, yeah, then I think we are.
yeah. Sometimes you'll have different intervals. You'll have multiple intervals, and then you combine them by putting a in union with. That's the beauty of interval notation.
Okay.
Did we answer everything for this problem?
Um, yes. Oh, and transformations.
Okay. What's the difference between our curve and the parent function? You said it already.
So a vertical shrink of 1/2.
Yeah, that's the only transformation happening.
Okay.
Okay. All right, what else we got?
All right, I also have, given the following functions, find the key features listed below without graphing.
Okay.
And it asks to find the domain, range, asymptote, and parent function.
Okay.
And the equation is y equals -2, parentheses 1/2, parentheses to the x, plus 1.
Okay. We're not going to graph this. Tell me what the parent function is.
Y equals 1/2 x to the x.
1/2 to the x, correct. And that's a decaying function. It's, in other words, the key number is what's in the parentheses. If what's in the parentheses is greater than 1, then it has the same shape as the last one. It just rises straight up. Okay? If it's between 0 and 1, then it goes down like that.
All right.
Okay, now I know they said don't graph it, and I'm not going to, but just so you know that the parent function doesn't, it looks more like a reflection over the y-axis of the last one we looked at. Okay, there's three things going on here. There's this thing, there's that thing, and there's that thing. Which one should we do first?
Or like which one? Oh, probably the negative.
Always the negative. Okay, so what's the consequence of that first, that negative sign?
A reflection over the x-axis.
Okay. What's the consequence of the 2?
A vertical stretch of 2.
And the consequences of the +1?
A vertical shift up 1.
Yeah, and here's a perfect example where if you were to do the shift first, it's going to give you a different looking curve than if you did the reflection first. So this is a perfect example of why you have to do the reflections first.
Okay.
Now, asymptotes. Where would the asymptote of the parent function be?
Would it be -1?
The parent function.
Oh, of the parent function, it would be 0, or y equals 0.
Okay, and because we have a vertical shift, the vertical stretch does not affect that. Okay,
Okay.
reflection doesn't affect it. In other words, when we reflect, we still have y equals 0 as our horizontal asymptote.
Mm-hmm.
Now the plus 1 moves that horizontal asymptote up 1 unit. So what's the new horizontal asymptote?
Y equals 1.
Yes. Domain, all reals. Range?
The range will be 1 to negative infinity? Or 1 to infinity?
Well, you were right the first time. It's negative infinity. But you always want to start at the bottom.
Okay.
Okay, so it's negative infinity to 1. In other words, if just a second. I feel like I'm doing something wrong here. Let's see. If I draw the original curve, I know they didn't want us to do that, but I'm going to just for my sake. And the first thing I do is the reflection, so it looks like that. And then I do the vertical stretch so that it looks like this. And then I do the shift up 1. So the shift up 1 changes the horizontal asymptote from y equals 0 to y equal 1.
Okay.
So yeah, we've got the range right. It's minus infinity to 1. Except how is it 1? As x goes to infinity. In other words, the bigger x, this illustrates something else, which a lot of people aren't really familiar. They don't realize that. If I square a number greater than 1, I get a bigger number, right? But if
Yeah.
I square a number less than 1, I get a smaller number.
Okay.
Okay? And what that means is that as x gets big, that whole thing gets very, very small. So as x goes to infinity, this whole quantity basically goes to 0, and everything approaches that horizontal asymptote at plus 1. So that definitely is correct for the range. In fact, all of it. Okay, what else?
This one's just using our calculator, but it says a new laptop costs $1,500. The value of the computer decreases by 22% each year. Estimate the value of the computer after owning it for 4 years.
Okay, give me your general equation.
A equals a 1 plus r to the t.
Times
I also had another one.
minus r
Oh.
to the t. In other words,
She also said,
what's that?
my math teacher also said we could use p plus prt.
Correct. In other words, nothing decays once a year. That is not how nature works.
Okay.
How nature works, or car values, is continuous decay.
Mm-hmm.
And if it's continuous decay, then I'm going to use this. I'm really glad to hear your teacher say that, because most of the students I get haven't had the continuous decay formula, so they're stuck with using this one, and it's not really the appropriate one to use. The appropriate one to use is this one. In other words, that car at the end of 6 months is going to depreciate at about 11%. It's not going to wait until the full year is up before it loses its 22% value.
Okay.
Okay? And the top equation presumes that. In other words, that's where it's compounded annually. Well, the only things that are compounded annually are like bank accounts. They're created by man. If you take a bacteria culture in a petri dish, it never compounds annually. It compounds continuously, just like rabbits do, or any population, up to a certain point. But everything in nature is continuous in nature. It either continuously grows or it continuously decays. So in the interest of accuracy, let's use the bottom one.
Okay.
We're going to figure out what its amount is at the end of 4 years. Well, tell me what I should fill in here.
For the amount?
That's what we're going to solve for.
Okay.
We want to know what the car is worth at the end of 4 years, right?
Okay.
Okay, what's P?
So P is 1,500, right?
Huh? E is just a number. R is what?
0.22?
Yeah, it's actually minus 0.22. Okay?
Oh, because it's decreasing.
Because it's decreasing, exactly. If I use a positive, I'm going to have this A be bigger than 1,500. And 4 years, they both are years. It's decreasing at 22% per year, and it's 4 years, so the units are the same. So I'm going to multiply that by 4.
Okay.
Now I'll get that number out of your calculator.
Okay, let me grab my calculator. Okay.
Definitely going to be worth less than half. I'm guessing it's going to only be worth maybe 500 bucks.
Okay.
What's E?
So do I just kind of like disregard the E?
No, you got to use the E. E is the number 2.71. So to come up with an answer, you got to put in E. Now, your calculator should have a key for E.
Okay.
What kind of calculator do you have?
The Inspire CAS.
No, I was looking for E the other day on here and I couldn't find it.
Oh, really?
Yeah, I don't know what the deal with that is. There's a pi key.
Yeah.
I don't know why there's no E key. For E, go ahead and put 2.718. And then, raise it to the negative 0.88.
Oh, yeah, I found it.
Oh, okay. Good. Where's the E key?
So you hit pi.
Oh.
And it should give you other options.
Oh, you're right. It does. One of them's E. Okay, cool. Okay. Well, then use that key.
Okay.
Take it to the negative 0.88, which is going to be what that exponent is.
Okay.
Multiply your answer by 1,500.
And it says 622.174.
That makes about sense. Pretty disgusting when you think about buying a new car.
Yeah.
That in 4 years it's lost more than half its value. Actually, when I was a kid, my dad used to use a formula that was a third per year. He said the average new car, or the average car, loses 1/3 per year, 33%.
Dang.
So this is a Honda or something here, only losing 22%.
Yeah.
They make cars a lot better nowadays than they used to. So the car probably isn't going to depreciate by 33% per year anymore. Just the market would not let it do that. All right.
Okay.
What else you got?
And then another one says, determine how much interest you will earn if you deposit $450 into an account paying 4% simple interest at the end of 10 years. And then it asks for the equation and the interest after 10 years.
Okay. Now this is an artificial creation by humans, banks. And so that formula does apply here. Okay, this is exactly what the bank does, is at the end of 1 year, calculates you 4% of 450, adds it to your bank, and then the next year you start with $18 more than 450. Okay, so the fact that you're compounding it annually, this is the correct equation to use.
Okay.
Had we used this equation on the last problem, we would have come close, but it wouldn't have been as exact.
Okay.
Okay? But here, we definitely want to use this. It would not be correct to use continuous compounding here. That's not what the bank is giving us. The bank is going to compound it annually. So the amount is going to be, what's the rest of it?
Equals 450, and then parentheses 1 plus 0.04.
Yeah, I'm going to go ahead and add that right there.
Okay. And then times 10.
Not times, but to the 10 power.
Oh, right.
And now, I tell people to do that part first, just so you can't make a mistake. You could probably put the whole thing in there, 450 times 1.04 to the 10th, but there's always a danger that the 450 is going to get taken to the 10th power, and you definitely do not want that.
Right.
So, what do you get?
666.11.
Pittance. For 10 years. Yeah, that's a ballpark figure for sure.
Yeah.
But it's not much either. In other words, your money didn't even double for 10 years.
Right.
All right. What else you got? You got any half-life problems? Since we just have time for maybe one more.
Just to what?
Half-life problems?
Is that what we're doing right now?
No, I was going to say we have time for about one more problem.
Okay.
And all of the ones we've done up to now have been fairly simple. Do you have a harder one? And what tends to give a lot of people trouble are half-life problems, where they give you a half-life of a radioactive particle.
Oh yeah, we're not gonna have that on our test, so she said we didn't have to worry about that.
Okay, cool. Well,
but I just have a quick question. So when do we know to use difference between A equals A1 parentheses 1 plus R to the T, and when to use?
There's 3 types.
Okay.
There is this. That's annual compounding. There is this. That is compounding greater than annual. In other words, monthly or daily, something greater than annual, and what N is how often a year do you compound. In other words, if you have a bank that's running a special and they're going to compound it monthly, then N is 12. If they're going to compound it daily, then N is 365. If they're going to compound it weekly, N is 52. And finally, if they're going to compound it continuously, that's when you get the PERT.
So what does continuously really mean though?
Means that every single second they're going to pay you interest based on what your account is valued at that second. Okay. And that's the way the natural world works. bacteria doesn't compound annually or it doesn't compound monthly. Bacteria compounds based on how much of it there is at any point in time. And that's what continuous growth means. And that's also the way everything decays. In other words, if you are talking decay, whether it's a depreciation of a car or whether it's a radioactive material that's losing some of its mass on a regular basis, always continuous. Like I said, annual compounding and more often than annual are artificial creations of humans. So the only time you're ever really going to use these formulas pretty much is on bank accounts.
Okay.
And that's the truth. That's the only time you ever should use it, because that's the only time it applies in real life, is to something where you have a human that's going to compound it annually only, once a year, as opposed to a person that would be doing it every single second. But instead of doing it every single second, they use this formula, and that does the same thing as compounding it every single second.
Okay.
Kind of the definition of E.
Yeah.
And that's why E is in that thing. And that's also why E is such an important number. I mean, E is the second most important number in all of math behind pi. And it's very hard to even explain it to most people how E is defined. Well, E is defined as the limit of this as x goes to infinity. In other words, what happens to that thing as x gets bigger and bigger and bigger? Well, it goes to 2.718 and change. That's the definition of E. And this is the process of, notice how similar it is to that. In other words, as n approaches infinity, this whole thing in the middle here approaches the definition of E, right? It's 1 plus some number over infinity to the infinite power. Well, that's what the definition of E is, and that's why E replaces that when you have continuous compounding. All right. You good to go, Anna?
Yeah, that was good.
Okay, good. I'll talk to you next Tuesday.
Okay, thank you.
Bye-bye.